Hey, how's it going? And welcome back to building a human segmentation model in Tensorflow. Today we're going to go into part 2 where we actually get the model training and kind of move beyond just wrangling the data and getting the data ready for model training. So if you remember in the first part, we kind of went through and basically got an understanding of what kind of model we're working or what kind of data we're working with. We've created some of these data reading functions so that we can actually read in the data and create what the proper inputs for our models for training. And then we went ahead and visualized things to make sure things are actually making sense. And then we created and wrote out some of these pre-processing functions that are going to be used to generate our TensorFlow data sets. And then also our TensorFlow image function here for the TensorFlow data sets, and then some of our data augmentation that we're going to be applying. And then basically generated our lists of paths, right, for our training images, our masks, and then also for our validation data set, right, the images and the masks. So today we're going to go ahead and the first thing we're going to do is we're going to go ahead and actually write out a function for bringing all of those paths together. So go ahead and define the function. It's going to be called getDataset. So we're going to want to pass our config file to it, our train images and masks, and then the same for our validation. And that should be it. So go ahead and define a few things here. Okay, so just kind of walk through these first two lines of code that I wrote. Basically what this is doing is it's going to go ahead and take a look at our config file. And in our config file, we're going to pass as a string which dataset reading function we want to use and apply to this dataset. And what it's going to do is it's going to index the globals. What the globals is basically a Python. It's built into Python. You can call this globals function and it returns basically all of the functions and variables in your global namespace, and we're able to access those functions through the keys. Basically, it's like a Python dictionary, and then we access it just like a Python dictionary, passing the string of our function to that, and then it'll call that function as long as we have it defined, and then apply that to our data set. So it's kind of a generic way of writing this instead of hard coding exactly the function we want to use. That way we don't have to come back to this particular function and change it every time. We can just change it in our config file. As long as we're defining the function somewhere else within our notebook, this function will be able to call whatever one we pass to it and apply it to our data set. So it's kind of the idea behind that. So we're going to do that for our validation and our training data set. And then we need to get the number of training images there are. So we're just going to call the length of the train images. These things are, so the number of the training and number of validation, right, is going to be used in our training. Some of the training parameters we pass, so the model knows and the framework knows how many steps there are going to be per epoch of training. Okay, so here again, we're just kind of calculating out the number of steps we're going to have per epoch based upon how many training samples we have and validation samples we have. And then it's going to return our training data set, validation data set, and then also those two parameters we're going to need for the training function. I like to just kind of print these things out so that when I'm actually running my script, you can just verify by a visual, just looking at the output file. And also this is very similar to if you followed along in the deep learning framework I wrote, it's very similar to that function. I've only changed a few things basically because our input data has changed a bit. This is kind of a different use case and it isn't set up as to be as general, but so just made slight modifications to that kind of base logic, and so it can be used here. Okay, so again, I'm kind of just going to copy and paste from the next function from those previous videos because we've kind of talked about the logic before. This next one's going to be the get compiled model function. Again, I'm just going to pass our config file, and then we're going to create our checkpoint directory. So this I'm actually going to change because this is working out of Kaggle, and I just want everything to go into our output folder, right? So I'm just going to change that to output, make a little bit of a change. And then again, we're going to pass our optimizer and then our learning rate. And then since obviously we're not going to be restoring any models, we don't necessarily need to worry about that, but you can leave that functionality in there. And then here we go. So it's going to compile and return your model. So we're going to pass our model as a string so then it can be evaluated and ran, and then print out a summary of it. And then we're going to compile our model with whichever loss function we pass, as well as whichever metric we pass in our config file. So we're going to go ahead and make that change. Seems I have a issue here. I'm going to go ahead and take a look at that and I'll get back. So it looks like I just had an indentation error. I just went ahead and fixed that, and now everything is working properly. So we can go ahead and move on to the run training function. So again, I'm just going to kind of copy and paste just because we've kind of talked about this before, but I'll kind of still walk you through it if you haven't seen the previous videos. So basically I have my run training function. So this is where I'm going to consolidate everything, right? So we have all these smaller functions, where we get our data set, get our compiled model, all that stuff. So basically I want to just bring everything into one main function. So it's called run training. We're going to pass our config file, our training images, train masks, validation images, and validation masks. Basically, you're going to go ahead. First thing it's going to do is going to load your data. So you call your get dataset function with the parameters it needs. So if you go back up, you see we need to train images, masks, and then validation images and masks. So we go ahead and pass those as well as the config file, and it's going to return these parameters. The next thing we're going to do is we're going to go ahead and compile our model. So model is equal to calling our get compiled model function. And then our logs directory, again, since this is in a Kaggle notebook, if this was on my own machine or some like EC2 instance in the cloud, I would kind of have these directories kind of extended. It wouldn't just all go into the output directory. But when it comes to running some of these outputs, I don't know. My past experience with it is if I have like, kind of subdirectories, it doesn't necessarily make them very well when I just set this notebook out there to run. So I just kind of have changed it to everything just goes into this output directory. So then later, once we're done running and training our model, we can access the trained model in a different notebook. And that way we don't have to necessarily sit here and keep this instance running to get and use our model. We can access it later by just looking at the outputs of this particular notebook. But okay, so then going on. So again, kind of just time configure, putting the time into this model so that we can kind of track, when was this model trained. So that's why we're grabbing the date. And then again, our model output. So we're using a Keras or TensorFlow callback model checkpoint. We want this to go into our output directory, and then we want to call it whatever our model is, and then today, time stamping it, and then H5 file. What we're going to be doing is we're going to be monitoring the validation loss. We want to make sure we save, the one with the lowest validation loss, so our best model, and then obviously save best only true, and then save weights only false. So we wanted to save the whole model. So we're going to go ahead and create our callbacks, which is a list of all of our callbacks. If you want to add anything else into this, you sure can. When I'm running my actual models for other projects, I usually do. I add quite a few different things in, but just keeping it simple for now. And then to go ahead and then fit the model, right? So actually train it. So we call model.fit, and then we pass the training data set, our steps per epoch, and then config number of epochs we want to run. and then we pass our validation data set, validation steps per epoch, and then all of our callbacks. So that is our run training function. And then the next thing we need to do is we need to define our config file. So what we're going to do is I'm actually going to copy and paste part of this, and then I'll kind of actually type through the rest. Well, actually, I'll just go ahead and just copy paste the rest of it. I kind of have already this coded up, and then I'll kind of slowly walk everybody through it. Okay, so if you remember looking back up at the run training function, or sorry, no, the get compiled function, you see that we evaluate whatever we pass to the config model. So we're going to have to pass it a string, and this one, in this particular example, is our function in string format. So when that's evaluated, it actually returns that object. So basically what we're going to do is call our unet model function. For our input size, we're going to have our config shape 1. So we want this shape here to be our input shape. Number of filters is here, filters, right? So we have 64. Number of classes is config number of classes, which we have 2. Batch norm is we want that to be true. And then we also want to pass the dropouts from the config file to this model. So here are the dropouts. So next thing, we want to use the tf image dataset function. Our output is going to be /, right? So this is going to be the actual output directory. So if you take a look, see, I just copied the path, and that is the output directory for this particular, and I think all notebooks you're running in Kaggle are that way. We want to do batch size of 16. We want to pass binary focal Jacquard loss. We want to use IOU score. And then we also want to use, we went over the shapes, and then we want to train it for 200 epochs, learning rate of 1e to the -2. We want to use atom optimizer. Obviously, we're not restoring, we're building a new model. And then these are our dropouts per each convolutional block. So I'm not entirely sure if I covered it in the previous video. I might have, but just again to touch on, this, we're using segmentation models, and then yes, I did. So we're going to actually be using binary, binary focal Jacquard loss is what I said. Yes, because it's a 2-class binary classification problem. So we went ahead and installed that library, and then we imported that. So then once it's called, now that we're passing it to a config file, it'll be called when it's training our model, as well as the IOU score. So let's go ahead and come down here, run that cell, and then the last thing you're going to have to do is just call the run training function, and we're going to pass config train images, train masks, val images, and then val masks. And what I like to do is right now I'm not using any accelerator, right? So the accelerator you can use are these GPUs or a TPU. Right now I'm just running it on CPU. I like to do that just to verify like my code's working properly and things are running. So I seem to have an error, so absolute error. Go ahead and take a look. I think it's just I called something or have a spelling error. Let me go ahead and make that adjustment. Let me find this here. Yes, so all right, that looks better. Let's go ahead and go back down and run. So there we go. We're loading in our data, training samples 444, and then validation samples 111, 27 steps per epoch, 6 for validation steps. This is our model summary. So this is our UNet, and we're going to go ahead and try to train the model, and then we threw another error here. So yeah, return pyfunct is a double but expects a float. So I have one of my data loading functions is not returning a numpy float like it should be. All right, so I was able to find the issue. So if you come back up to the preprocess function in this sub function called f, I had return mask as type mp.float, and what you need is mp.float32. So like I was saying, some of these data types are pretty finicky. If you don't get them exactly correctly, then you're going to have some issues, but it's pretty easy to go back through and kind of just walk through the functions and kind of look for kind of differences or things that might be an issue, trial and error. And the output errors aren't necessarily the most straightforward sometimes, but if you get super stuck, just Google it. I do that a lot too. So, Okay, let's go ahead and try run training. So try this again. And so we haven't thrown our error yet. I'm pretty sure by now it usually did throw its error. So things are going to be pretty slow because it's on the CPUs. Okay, there we go. And we see it's working. So I'm going to go ahead and cancel the run. And then what we're going to do is we're going to come up to here. And now that we know the whole workflow is working, and we want to, basically we want to run and train a model for 200 epochs, but we don't want to have to leave it up here. What you go do is you come up to here and you go save new version of your work, right? So version 1, and then you'll see here it says run and save and run all, right? So click this down. So yes, save and run all. And then you also want to go to the advanced settings. So you have 3 options here. You have never save output, always save output, or save output for this version. So that's kind of up to you, but on which of the bottom 2 you would like to pick, but we're gonna need to save the output so that we can access the trained model at the end, and then run without an accelerator. So you're gonna drop down this, right? So you're gonna go ahead, and we have this currently configured for GPU. So what you're gonna wanna do is, again, choose between what you wanna use for both of these GPUs, but I'm gonna go ahead and say run with GPU for all sessions. Go ahead and click save, and then version 1, click save. So now you can see this is popping up. So we have notebook running with GPU P100. Go ahead and click on that, and you can go ahead and see now it's going to run. And this is going to take, I don't remember exactly how long mine took, but basically what you're going to do is let this run, and it'll run until completion, since we know there's no errors in the workflow, and you'll be able to access the trained model at the end. So yeah, so here we go. We can kind of see now the models are training. We are installing the segmentation models library here. This is kind of the output. You can sit and kind of watch the logs if you would like. We'll kind of sit, now it's printing out the summary, and now training is about to commence. So yep, now we're loaded. So this is, when you start to see this, right, it's loading in the cuDNN version 8005, what have you. This is a good sign. That means your CUDA libraries and your GPUs are loading properly, and that all of your script has error-free, and things are going to actually start running in training. So I'm not going to continue watching this. So yeah, here you go. You can see the first epoch of training. You'll be able to see the loss, the IOU score, validation loss, and so forth. But I'm going to stop it here, and I'll get back when this is actually fully trained, and we can go ahead and take a look at the model. All right, so now that the model's done training, this is actually a different notebook. This is what I ran previously, but it's the exact same code. So if we come down here, we go ahead and go to that notebook, and we can go ahead and look at the training and how it commenced. We can go all the way down to the bottom. So it runs our 200 epochs. Go down to the bottom, and we see, we kind of ended up with, I don't think this is the best. Okay, so here we look, have a validation score of 0.64, 0.62, 0.63. Yeah, so it's probably somewhere in the 0.64 range where it's our best trained model. And we go ahead and look at the training IOU scores, 0.63. So it's kind of, this is one of those weird case scenarios where there's actually, oh no, it's 0.62. But anyways, so they're basically, yeah, here we go. So yeah, IOU score of training IOU score of 0.62, and then our validation of 0.64. So it's one of those weird scenarios where the validation is actually better than training. This can be, from a lot of different things, one of which could be, there's maybe some inconsistencies in the training data. Also, it could be that your regularization, so like things like dropout and different data augmentations and stuff, were so good that it actually made the training hard enough to where it actually learned really generic features. So as long as they're really relatively close, and especially for this particular problem where it's kind of, just kind of a toy example, just kind of show you the workflow of things. It's not some end case or like something you're going to deploy in the industry, right? As long as there isn't some major overfitting happening here where the training score is like super high and the validation score is really low, stuff like that, then it trained pretty well. It learned some meaningful features and representations of the data. So if we go ahead and take a look at the data, so we go ahead and look at the output, we can see here we now have access to our CSV, which is kind of the training that's here, right? We can take a look at the training scores per epoch. And then we also have access to the model, the H5 file. So now that the training's done, in the next video, we're going to kind of go through and walk through how to access this model, bring it into a new notebook, and then kind of build a little bit of wrapper software, a little bit wrapper functionality around the model so that we can maybe ingest some different images. They don't necessarily have to be from the training data set. Ingest images, run our model on it, and see if it can actually segment people. So I don't know if we're going to actually do this on the Kaggle notebooks. We might actually just download the model to our local machine and run things there. Haven't quite decided yet, but should be fun, should be interesting to kind of show, now that we've trained a model, now how do we simply deploy it to some kind of end use case. So I hope you enjoyed. I hope you got something meaningful out of it, and I'll see you in the next one.